Okay, we completed question 5, so we're starting with question 6. Okay, that's done. This we need to look at. Okay, now nice question. They've given you a diagram here. What do they ask you to calculate?
The diagram shows triangle ABC in which AB is perpendicular to BC. The length of AB is 4 cm and angle CAB is in radians. The arc DE with center A and radius 2 cm meets AC at D and AB at B. Find in terms of A the area of the shaded region.
Okay, so find in terms of A. So A is obviously important. Well, not A, alpha. Alpha is the arc. Okay, so arc radian, basically. Alright, so you've got to find the area of the shaded region. You need to find the area of the triangle and minus the area of the slice of, like pizza, that sector, right? Okay, so that's what you're going to be doing here. Just to write that down, question 6 gave you a triangle, and they gave you a sector. Right, so the triangle is easy to work out the area, right? How do we work out the area of a triangle? Correct. So, area triangle equals half base times height. Half times the base. What was the base? 4. Do we have the height? No, we don't. Okay, we need the perpendicular height, so we need BC. Okay, so that will be times BC. Okay, and then we need the area of this little sector, so that requires a formula. Can I get the textbooks? Okay, just to get those equations. You can probably look at your notes, but I'll use this, it's easier. Here's the paper. Okay, so arc sine, which is the sector, circular arc length, circular sector area, 284, here's it, radians. Okay, right, so I want the area of that particular sector. So in order to get the area, the formula is area of a sector is equal to theta, which is the angle, over 2 pi times pi r squared. Okay, so I need to know what this angle is. What angle did they give you there?
So we're not going to find out the height now. We're going for area of the sector, this thing.
Yeah, well, we need the area of both, and we'll find out those missing figures just now. So,
okay.
Remember, get all the easy marks. So, obviously, you know what the area is of a sector, you know what the area is of a triangle. Write down the stuff that you know that you're going to be using as part of this question. Then you can go back and look for the missing amounts if you need to. Okay, obviously, BC isn't given, so you have to find it. Okay, what did they label the angle as? It was just alpha, hey? Alpha radians. It was alpha. And then they also gave you the length of this. So from here to there, that was how many centimeters? 2 centimeters. Was there anything else there? No, there wasn't. Okay, that's it. So that was all that was given, and obviously the 4 centimeters here at the bottom. Okay, so let's substitute into the area of a sector. The theta would be alpha over 2 pi times pi and then r squared. So what is r in this case? 2. 2 squared. Right, so if I simplify this area of a sector, this pi can cancel with that pi. That 2 at the bottom can cancel with one of the 2's at the top, and you'll be left with 2 pi. Not 2 pi, 2 alpha. Okay, now we've got the area of a sector already.
Okay, just that. Okay.
Right, so now coming back to the first part, which was this. Let's highlight it. Where's the mouse now? Computer's thinking. Okay, well, let's go look at the BC. So BC is that. So I'm going to need this, the perpendicular height. I think I've labeled mine incorrectly. A, B, oh no, that's correct. A, oh no, A is here. Okay, my letters aren't right, let's just change it. A is here, B is there, and C is here. Okay, yeah, so BC is the perpendicular height, that's what I need to find. Okay, so then we need the area for the Pythagoras could work if you've got the hypotenuse. You don't have the hypotenuse. You've got 4 centimeters as the base, and you've got an angle. So I'm looking for a side. I think we can use Cos rule. Let's check what Cos rule was again. Because Cos rule gives us a side. That would be part of the trig. Then I can use this textbook. Okay, so we just need an expression. We need an expression for BC in terms of the alpha or the 4 centimeters. Okay, so let's see what Cos rule is again for these triangles. Their formula and solutions of triangles 3, 2, 7. 3, 2, 7. Okay, there, the cosine formula. The cosine formula can give me C. So C would be an angle, but then I need the 2 sides. Okay, I don't have A and I don't have B. I don't have those 2 sides, so that's also, you can't use that. Can I use sine rule? Sine rule will be that angle with that side, and then that area with that angle. So 90 degrees, that'll work. Okay. There we go. Alright, so sine rule would be applicable here. Okay, so let's highlight this in a different color. Okay, so you've got this side. Okay, we need this angle. What will this angle be? This angle would be 90, because here's 90, and there's alpha. Right? Alpha is this angle, 90 degrees is that angle. Okay, what must the internal angles of a triangle add up to? 180. So 180 minus 90 minus alpha equals angle C. So 90 minus alpha equals angle C.
Where is alpha on the calculator?
You don't use alpha. Alpha is an unknown. It could be anything.
Because I just thought that started maybe there was a...
No, alpha is an unknown. It could be anything. Only pi. Pi has a value in the calculator. E has a value in the calculator. E is for ln, pi is for radians. Alpha is just a random variable. They said solve for the area in terms of alpha. So they don't expect you to solve for alpha. Okay, so now I know what C is equal to. C would be 90 minus alpha. Okay, so now I've got sine rule. I've got an angle with an opposite side, and I've got another angle with an opposite side. So now we apply sine rule.
Okay, so 18.
Okay, so what does sine rule say? Well, sine rule says angle A over sine, not angle A, it would be the side. So side BC. Let's use that. Apply sine rule. Okay, so BC is that there. Okay, BC, and then you've got this sine, so that the side over the sine angle, which is sine alpha. Okay, and that's going to be equal to, then I've got the other side. What other side do I have? I've got 4 centimeters. So 4 centimeters. So let's write it down and we can substitute AB over sine C. Angle C. Angle alpha, angle C. Okay, that's applying sine rule. Okay, sine rule says the opposite side with the angle is equal to the opposite side with the angle. Just a basic formula that we study from mathematics. We apply it. Okay, so that is the sine rule applied to this triangle. I need to work out BC. So what would BC be equal to? Well, let's work it out. I'm just going to rewrite it again. BC over sine alpha is equal to AB over sine C. Okay, do I know what BC is? No, I don't. Do I know what sine alpha is? No, I don't. So sine alpha will stay the same. Can't simplify that any further. Do I know what AB is? Yes, I do. AB is 4 centimeters. Do I know what C is? I just worked it out. 90 minus alpha. So 4 over sine 90 minus alpha. Okay, so if I solve for BC, BC is going to equal 4 sine alpha over sine 90 minus alpha. Okay, now you've got the co-angles, that 90 minus. So 90 minus, let's go back and check that. With trig, when you have equations, when you have angles 90 minus, that's those co-functions. So 262 yeah. Okay, remember these rules of the co-functions. Have a look. Sine 90 minus theta is cos theta. So this would be the same as 4.
So that's identities.
Yes. Sine alpha over cos alpha. Right, I've converted this into that based on the rules that we need to study.
I'm just seeing if they give a picture.
Yeah, if it's not there, then you need to add it to the formula sheet. Remember, you need to go back and look at all your notes and check. Okay, this section covering this topic, does the formula sheet give me all the equations? If not, add it to what they've given you so you can just study those.
I'm not missing it. Is it there? I don't think it's there.
Let's see. You've got the arc stuff. There's the arc stuff. The arc stuff you don't have to study. The 90 minus isn't here. No, it's not there. Yeah, they've given you stats here. The stats you don't have to do. That's probably A levels. We haven't covered any stats. Now, so for you, the first 2 pages are important. Mechanics you don't do. Probability statistics you don't do. Because it's just 1 page that you would have to know. That would require.
So that's an identity.
It's the co-angles, identity. So for example, sine 90 minus theta is exactly the same as cos theta. It's exactly the same.
So why did you change it? Why did you have to change it?
Because I know that sine over cos is what? Tan. So now it's 4 tan alpha. Okay, so BC is that, 4 tan alpha. Right, so if I know what BC is, what am I going to do? Take this and I'm going to substitute that into the equation. Okay, so do I have BC? Yes, I do. I can take BC and I can substitute that into the original equation.
Is that done?
Yes, BC. You have to work out BC, right? Because earlier you saw the half B times H, okay, half base times height, and then you were saying, don't we need to calculate BC? Yes, we do. Okay, we just did the calculation now. Right, so let's go back to the question. Here's the question. This is what I started with. Do I know what BC is? Yes. In terms of alpha, I do. This is 4 tan alpha. Right, did they want the area of the triangle?
So why couldn't we say, why did we have to get tan? So we changed this, we did an identity to make a tan, but why did we need?
Because tan is just one variable. You can write sine over cos if you want. You can write sine over cos if you want. It's exactly the same.
Yeah, I'm just asking you.
Yeah, I've just made it tan because I know that tan is sine over cos.
Because it's easier. One identity instead of 2.
You could have left it as sine over cos. I've just changed it because it's an identity. It's something that you would have studied and known. Okay. Right, so did they want the area of a triangle?
Pardon?
Did they want the area of the triangle?
Yeah.
No, they wanted the area of that bit. You highlighted it in pink on the question. Okay, they wanted this part, right? So the area of the triangle is the whole thing, right? So how am I going to get that area there? Take the whole area of the triangle minus the area of the sector. And you've got those two things. Right, so let's show it.
So what is the area of the triangle? Oh, because now I've got 4 tan alpha.
Yes, so you know what that is, right? Okay, we just need to simplify it. So a half, I want to simplify that. So area of the triangle is equal to a half times 4 times 4 tan alpha.
Okay, just...
So 4 times 4 is 16. 16 divided by 2 is 8. Okay, then you also know what the area of the sector is. That was easy, that was just 2 alpha. And I just put them all together. Area, bracket, shaded region.
So it's actually
equals the area of the triangle minus the area of the sector. Yes, the final answer is this: 8 tan alpha minus 2 alpha. That's it. That's as far as you can go. You can't simplify that any further. Tan is tan. You could write tan as sine over cos. It would have been fine. They didn't say in terms of cos or in terms of sine. They just said in terms of alpha. So we've got alpha. Just had trick here because they didn't give you the lengths of the sides or the heights. Okay, perpendicular height wasn't given, so I needed something to get the height. Right, so the approach is always the same. Understand the question, look for keywords in the question. Keywords in the question, arc, okay, radians. That tells you you need to use that formula for the sector. Okay, and you just write it down. That they did give you in the formula sheets. That you don't have to study, it's given. That you could have just written it down as is.
But what did they do for the arc?
Arc sine is there. You had it.
Arc length of a circle.
We don't want the length, we want
Area
the
of
area.
sector.
There we go.
Okay. R squared.
Yeah, you still need to go back and compare your file formulas to that. Okay,
So how come our formula is different?
I just used the other one. So what was it, 284? They had both there, so you could have studied either or. You're going to get the same thing. Okay. There's the one that I used, there's the other one. That's the one they gave you in the formula sheets. Okay, so the formula sheet's not going to give you all. The formula sheet's going to give you one or two. If you worked out that one, you're going to get the same answer. Okay, because this one, I really cancelled the pi's. You see that? Okay, so it doesn't matter which one you use, it's the same thing. You just write it in a different format. Okay, you're going to get the exact same answer, either or. Okay. Right, what's the next question covering? Was that one or was that the whole question? That was just the first one. Okay, so let's label that. This was 6-1.
This is the whole question. Oh no, there was 2. Sorry, that's the 7. The perimeter of the shaded region.
Okay, so question 6-2. They want the perimeter of the shaded region. So now we go back to the diagram. Just to highlight what they want, this is what they want now. The perimeter. This bit over here. Right, so they want us to find that. Okay, do you agree? If this is 4 centimeters, then I know what the length is of, because the radius is the same, right? So let me redraw it. Which one was B? B was bottom. Okay, so if you've got that, you know that this is 2 centimeters. So if that's 2 centimeters, this must also be 2 centimeters. And if the whole thing is 4 centimeters, then you know this little bit over here is 2 centimeters. Okay, we already worked out BC. BC was, let's get the figure, 4 tan alpha. 4 tan alpha. That's the length of BC. BC's length is 4 tan alpha. Then I've got this little bit here, which is the 2 centimeters. I still need this little part over here. That part I don't know. That's a question mark. Alright, can I get this? Yes. Okay, that's the arc length. Alright, so let's highlight that and let's get that side. Okay, so if I highlight the arc length, I can use the arc length formula. That gives me the length of that. So arc length is S equals
Arc length of a circle here they used r theta.
Yes. Okay, so that's the formula that you study, or you just read off the formula sheets, and then I can write down S equals, do I know what the R is? 2. Do I know what the angle is? Alpha. So that's the arc length. So now I can put that on my diagram. This represents that, 2 alpha.
How did you get alpha if it was theta there? How come you changed it?
Because theta is just the angle. So what is the angle in the question?
So
Alpha.
R, what is R?
R is the radius.
The radius, which is 2.
What is the angle in the question?
Alpha.
Alpha. Okay. Alright, so now the challenge is to get this bit. That length over there. Okay, the question mark. So let's get that length. Right, so I've got 1, 2, 3 lengths. I need the 4th length to find the perimeter of the shaded region. Right, so how do I get the length of AC? I need to use sine rule again. So let's write it down. Sine rule. Okay, so sine rule, I know this is 90 degrees. Okay, and I know this is alpha. And I know the side here is 4 tan alpha. Okay, so the one side with the angle is going to be the sine rule. Okay, so let's apply sine rule. I'm looking for side AC. So AC over its perpendicular angle, which is 90. So sine 90.
DC.
AC.
DC. From there to there is DC.
Yeah, but I can't find DC if I don't have AC.
So to find AC first.
Of course, because AC is the full length. Okay, and sine rule applies to the entire triangle. Sine rule doesn't apply to half the triangle side. Sine rule applies to the whole side. Okay, that will be sine 90 equals. Okay, then I need another side. I know what this angle is, it's alpha. Okay, and I know what BC is. BC is 4 tan alpha. So BC over sine alpha. Okay, there's application of sine rule. It's the relationship side with the opposite angle. Side with opposite angle. Okay. Now we need to simplify, so plug in those values. So what is AC? AC is unknown. So AC stays AC. Sine 90 is a number. On your calculator, type in sine 90, it should be 1. Sine 90 wants a special angle.
Yeah.
Okay, so let's put 1 in. Equals, let's put in BC. BC is 4 tan alpha over the angle, which was sine alpha. Okay, so AC is just equal to 4. Okay, so now I'm dividing tan by sine. So I need to write it out like this. 4 tan, to simplify. Divide by sine.
Where did you get sine alpha from? BC.
From sine rule.
Opposite of BC is?
Alpha.
Sine alpha.
Yes, because that's sine rule. Okay, so I'm dividing by sine alpha. If I divide by sine alpha, I can change divide 2 times. Let's convert tan back into sine and cos, because then I can simplify, so I can get a simple, easy, one-line answer. Okay, so that will be 4. Tan is sine alpha over cos alpha. Right, then I'm going to multiply. So if I multiply, I'm going to switch this around. So it'll be 1 over sine alpha. Then I can cancel,
and
I can cancel.
What did you do there?
What is tan? Sine over cos.
Okay.
That's all I did. Just plugged in sine over cos for this.
And then 1 over sine, why did you inverse it?
Well, it's 4 tan alpha divide by sine alpha.
Yeah, but I'm asking why you inversed it, yeah.
Because it's divide. So how do you make divide times?
But why are you timesing it?
Because I want to cross cancel. Okay, have a look at this. This is basic maths. When you look at this, if I have, let's say, x, 2x, and I'm dividing 2x by, let's use 4y. Okay, what is this the same as? This can be written as 2x divided by 4y. Okay, if you're dividing by 4y, then you would inverse. So then you would have 2x times 1 over 4y, and then you can cancel. Okay, you can cancel this as is because you can see that that can cancel with that. Okay, but you can't do that with sine and tan. You've got to convert it. So that's why I've done that here. I've made tan sine over cos, and then I've written this divide there, and then I've just applied basic mathematics. If I divide, so if I divide, let's write this down. If I divide by 1 over 2, it's the same as timesing by 2 over 1. That's the basic maths, right? If I divide by half, it's the same as timesing by 1 over 2 over 1. I inverse it when I change the sign. Okay, because then I can cancel. I can cancel this with that.
Okay.
You want to write that down so you can catch up? Let's write it down. And then I'll write down the last part. Good, thanks. Yes.
All good.
Fine, thanks.
How's your mom?
Oh, she's okay, yeah.
Thanks.
Thanks for asking. Okay, so we cancelled. Next step, 4 times 1 over cos. Okay, is 1 over cos an identity? Yes. 1 over cos is the same as sec.
So why did, okay, because we cancelled them, so sine there. So 4 times 1 over. So 1 over cos is sec. Right.
Right, so now we've got all the sides. Let's go back to our diagram. Let's add that. Now I know that this whole side, from here to there, that whole thing is 4 sec alpha. 4 sec alpha. That's what I know. Okay, is it possible now to get this DC? Yes, I can, because I've got the whole side. So to work out this, let's highlight it like that. Okay, they did label that D, hey? Yes, they did. So DC equals 4 sec alpha minus 2 centimeters. There's DC. Now I've got DC.
Okay.
Alright, so let's answer the question. What did the question want? The perimeter of the shaded
So you
region.
just leave it like the pseudo minus 2 centimeters, you can't.
I can't minus 2 from 4 sec alpha. Okay, 4 is times sec alpha. If it was plus, then yes, but it's not. It's 4 times sec alpha. Unless I knew what sec alpha was, I wouldn't be able to solve for DC. Okay, right, so the question said solve for the perimeter of the shaded region. So do I have the length of all the sides? Yes. Okay, so just to sum up, just to answer the question, perimeter of the shaded region, which is what we just worked out in terms of area, is equal to, okay, let's add up all the sides. Okay, let's write down DC first. So this side is 4 sec alpha minus 2. That's the one side. Plus another side. Another side is BC, 4 tan alpha. Another side, plus, there's 4 sides to this quadrilateral, plus 2 alpha, and plus 2 centimeters, plus 2. Okay, can I simplify this? Yes, I can. This plus 2 can cancel with that minus 2. So final answer would be 4 sec alpha. That minus 2 cancels with plus 2, so you can eliminate that, then just plus 4 tan alpha plus 2 alpha, and that's as far as you can go. Unless you know what alpha is, you can't work it out. Okay, they didn't want like a numbered answer. They wanted in terms of alpha.
Okay. So when they say in terms of something, it doesn't have to be a specific number.
Yeah, in terms of just means keep the variable as the variable. Yeah, see, they said find in terms of alpha. Okay, so see, we've got the perimeter in terms of alpha. Okay, 6 completes. Now we can look at question 7. What's the focus? Most important thing is to understand the question. 7 looks quite short. It's only what, 6 marks? It's just 1 line, 2 lines.
So that one's done. Okay. The coordinates of points A and B are A, 2, and 3B, respectively, where A and B are constants. The distance AB is that unit, and the gradient of the line AB is 2. Find possible values of A and of B.
Okay, so they've given you a lot there. What are you going to highlight? Key things that stood out for you.
Find possible values of A and B. Find possible values. What kind of a question is this?
It's interpretation. So interpret. So that's the first thing. Is what does this question entail? Like, what's the focus? Is it trig? Is it
coordinates? So isn't this functions?
It's graphs. Yeah, functions. Exactly. Okay. So see, that's understanding the question. Now I know I need to apply function principles, laws, and rules to this question. Okay. Then I take out information, right? Okay. So let's just read it again. The coordinates of points A and B. So let's write that down because I need A and B at some point. Okay, so what are the coordinates of A and B? A and 2. Okay, so I know the y value of A. I don't know the x value of A. Same thing with B. What is B? Brackets 3 and B. Right, so with that one, I know the x value of B, I don't know the y value of B, respectively, where A and B are constants. Okay, so that's constants. Constants mean it's a number. The distance AB. Okay, so there's the key. You didn't highlight the word distance. We need to. Distance is a formula. Okay, so let's go to our textbook. Let's write down the distance formula. Let's go find it first. Okay, distance between 2 points. Page 2. That was like the first thing we did. Page 2 in the textbook covered distance. Okay, let's write down the equation. Here's the equation.
Because here it says the distance of AB is square root bracket 1.
Yeah, that's what the distance is equal to. Okay, distance is the formula. So write down the formula first before writing down the answer. Okay, so the formula from page 2 of the textbook. AB equals square root brackets x squared, or well, x2, it's actually 0.2. 0.2 of x minus 0.1 of x squared plus bracket 0.2 of y minus 0.1 of y squared. That's the distance formula straight from the textbook, page number 2. Right, then I read the rest of that question. Now I can write that answer.
So why did they say this units? Is that the answer of this now?
Yes, because the distance is a formula that has a length, and the length is what's given in the question. They said the distance in the question was that. Right, so this is distance, and that is equal to, now you can write down whatever they gave you in the question, because that's the answer. Can I see what it is? And then we can write it in. It is root 125. 125. Right, then they also tell you that the gradient of the line AB is 2. So they've given you distance and they've given you gradients.
This is a graph question.
Yes. Okay, more clues in the question. The word gradient would have stood out. AB's gradient. So in other words, M of AB is equal to, given as 2. Then they said find possible values of A and B.
Gradient of AB. So I'm just going to write down the gradient formula.
Yes, that's y2 minus y1 over x2 minus x1. x2 minus x1. Okay, so that's understanding. That's reading the question and pulling out stuff that you need in order to complete the question.
So we've got gradient, we've got distance, we've got points. Okay.
Right, so now we need to solve. So let's plug in the values that we know. What value do I know?
So what are we solving for now? For the
A and B.
Okay, so solve for A.
Okay, so this would have been x1, and this would have been y1. This would have been x2, and this would have been y2, because we've got 2 different points. Okay, so where do you see y1? I see y1 here, and I see y1 here. So there's a y1 and there's a y1. What is y1? 2. What is x1? Here's x1 and there's x1. What is x1? A. x2, same thing. x2, x2. Right, so all I'm doing is I'm just going to substitute in, right? Into the actual equations. Okay, so let's write that down on the next page. Okay, so distance.
Do you have to substitute into both of the formulas or just one?
Yes, both, because both have a x2 and y1 and x1 and x2, all of that stuff. Okay, so let's write down the distance equation in terms of the numbers that we've got. Okay, so what is x2? x2 is 3. So brackets 3 minus, what is x1? A squared plus brackets. What is y2? y2 in this question is b minus y1 in this question is 2. And all of that equals root to 125. Okay, then we have the other equation, the gradient. Here, 2 equals y2 minus y1. y2 was b minus y1, which was 2, all over x2 minus x1. x2 minus x1 was, x2 was 3, x1 was a. They did ask you to solve for, okay? So if they solve for, then we can find values. Yeah, find possible values of a and b. Good. So we can work that out. Right, so now the question becomes simultaneous equations because you've got two separate equations, both with a and b. Right, so is it possible to simplify the top equation?
So we're going to do simultaneous equations.
Yes, to solve for a and b, because you've got two. Can I simplify the top?
Yeah.
Yes. I can square the left, then I can square the right. What I do on the left, I can do on the right. The reason why I want to square it is to get rid of a root. I can't work with the roots. So next line would be bracket 3 minus a squared plus b minus 2 squared equals 125.
Let me just rewrite it. Okay.
Right, so let's expand it. 3 minus a squared, so 2 brackets. So let's multiply it out. So 3 times 3 is 9. Minus a times 3 is 3a, so minus 3a. Minus 3a. A squared, so plus a squared. It's just your normal formula. You can write out 2 brackets if you want to. Multiply them out, you're going to get that. Okay, then the same thing with b. It's b minus 2 squared. So I need to multiply out. So it'll be b times b is b squared. Right, then minus 2 times b is minus 2b. Minus 2 times b is minus 2b. And in the end term, minus 2 squared is plus 4. All equal to 125.
Okay.
Right, the bottom equation. Okay, let's finish the top one. Let's neaten it up. So let's see, the 9 and the 4 can be added together. So that'll give me 13. Then I've got a squared. A squared is a squared. B squared is b squared. Minus 3a minus 3a is minus 6a. Minus 2b minus 2b is minus 4b. Equal 125. Right, so that's as far as I can go in terms of this equation. I can take the 13 across to obviously eliminate it, to make it smaller. So it'll be 125 minus 13. I can actually show that as well, but I'll show that in the next step. Okay, let's work with the other equation because this is simultaneous equations. That's equation 1, that's equation 2. Right, so how do I take the denominator to the left? Well, if it's divide on the right, it becomes multiply on the left. So I take this whole denominator to the left. So it'll be 2 times 3 minus a.
So we're done with that equation now?
Well, I need a or b to solve for a or b. So that's why I need the second equation.
So
simultaneous
equations. Don't you need something to equal to a variable?
Yes. So what do you want to make equal here? You've got
so
squares.
Yeah, but we're just simplifying, yeah.
Yes,
so now
because this is massive.
Variable, yeah, for our first equation.
Exactly.
Okay.
Okay, b minus 2. So multiply out 6 minus 2a equals b minus 2. Right, so I can solve for an equation for b. Just take the minus 2 to the other side. So 6 plus 2 is 4. No, 6 plus 2 is 8. Minus 2a equals b. There we go. Now I have an expression for b using basic arithmetic. So what am I going to do now? Well, wherever I see a b, I can put in what? This.
This be
8. 6 plus 2 is 8.
Okay. So now I've got a variable.
Yes, so let's plug it into the long one. I'm going to do this on the next page because it's long. Let's keep the color though. I'm going to still put it in red though. Okay, so 13 plus a squared plus b squared. Do I know what b is? Yes, I do. b is 8 minus 2a. What else do we have? Minus 6a. What else? Minus 4b. b we know is 8 minus 2a. All equal to 125. Okay, so let's simplify all of this. This will give me 13 plus a squared. Okay, I need to multiply these two brackets out. So 8 times 8 is 64. Minus 2a times 8 is minus 16a. 8 times minus 2a is minus 16a. Minus 2a squared is plus 4a squared. Minus 6a. Minus 4 times 8 is minus 32. Minus 4 times minus 2 is plus 8a. Equals 125. Okay, so simplify. Let's get rid of all these like terms. Okay, so I've got 13 here. 13 plus 64. 13 plus 64. Any other numbers? 13, 64, minus 32. Minus 32 is 45. Okay, I've got a squared. So a squared minus, no, plus 4a squared is 5a squared. Okay, then I need all the a's. There's minus 16a, minus 16a, minus 16a, minus 6a, plus 8 is minus 30a. Equals 125. Right, so there's my expression. Let's get a trinomial. 5a squared minus 30a plus 45 minus 125 is going to equal 0. So the trinomial in its simplest form, which we can then factorize, is 45 minus 125 is minus 80 equals 0. Right, because I have an equation that's equal to 0, I can make it simpler. So I'll do that just now. Okay. Alright, you got it. Great. So divide everything by 5 because I don't want 5a squared, I want a squared. Divide by 5, divide by 5, divide everything by 5. Right, so then I'm left with a squared minus 30 divided by 5 is minus 6a. 80 divided by 5 is what? 80 divided by 5 is 16. Equals 0. Now we can factorize. Brackets equal to 0. Okay, so I gave you some practice because you were still struggling with this, so let's see if you can do one now. Factorize it. Just press on AC. I was clearing your memory. Yeah.
AC.
Yeah, that's fine.
These two terms must add to equal this and times to equal the last two.
Correct. You've got the right numbers, you just need to put in the signs. It's good.
So minus 2 plus 8 is 6, so that's wrong because I need negative 6. Minus 2 minus 8 gives me minus 10, so that's also wrong. I know, but don't have to put a plus in between. So I don't know what to do.
Minus 8 and plus 2. Okay, so now we've got it. Now we can say, just to sum up, I'm just going to do that on the right here. A equals 8 or A equals minus 2. Right, so now we've got the A's, we just need the B's. Right, so how do I get B if I know A? I can substitute into the other equation, right? So let's go back. Where's my equation for B? Here's my equation for B. B was equal to 8 minus 2A. You see it there? You've got it on your page as well. Okay, B equals 8 minus 2A. Right, so let's write that down. B equals 8 minus 2A. Okay, so what A's do we have? We've got 8 and we've got minus 2. So B equals 8 minus 2 brackets. A was 8. Minus 2 times 8 is minus 16 plus 8 is minus 8. Okay, then you've got B equals 8 minus 2A. B equals 8 minus 2. Let's see what A is. A is minus 2 equals. Okay, so minus 2 times minus 2 is plus 4. 8 plus 4 is 12. There we go. So let's just sum up. Final answer. When A equals 8, B equals minus 8, when A equals minus 2, B equals 12.